Welcome to the second episode of Season 2 of the PigX podcast. I'm your host, Delaney Howell. This month, we're talking about ventilation, because ventilation plays a vital role in maintaining good air quality as it helps to rid spaces of odor and pollutants. Without good air quality and ventilation, indoor spaces can become stagnant, filled with bacteria that can be detrimental from a health standpoint. But before we dissect just how important and how much that can impact swine health, let's welcome our guests. Brett Ramirez, Assistant Professor in Agricultural and Biosystems Engineering at Iowa State University, as well as Fernando Gomez, who is a Wean to Finish Technical Services Director for PIC. Gentlemen, thank you both so much for joining today. I certainly appreciate your time.
You're welcome.
Yes, thank you. Happy to be here and have a great conversation with someone we need to catch up sometime soon with.
Absolutely. And Brett, I'll start with you here. Tell us a little bit more about your background and your current role at Iowa State.
Currently lead a research and extension program here at Iowa State. Involves all things related to swine, environmental management, ventilation, technology, odor emissions, everything in that arena. And also on the extension program, I help coordinate and host a ventilation workshop where we take hands-on training to producers throughout the state.
Fantastic. And I'm sure we'll touch on that training a little bit more later on. Fernando, what about you and your background?
Well, my career started in Chile. I am from Chile. I worked during 12 years in PAC, developing business and giving technical services in Latin America. After, during 7 years, I worked with Smithfield in Mexico. And in 2013 to 2012, PAC hired me to develop the Wean to Finish area in North America. Today, my base is in Iowa.
Fantastic. What a neat background you have there. And I'm sure you've got a lot of experience that you can share with our listeners today as we dive into the bigger topic, which is talking about ventilation. Fernando, I'll start with you. And Brett, feel free to jump in as you've got other thoughts too, I'm sure. But talk to us a little bit about ventilation overall for the swine industry. Why is it important? Why is it a topic that we should be talking about on today's podcast?
Yes, but maybe it's good for a start point to talk about the ventilation as a difference between ventilation and a temperature. We talk more about the environmental management, okay? Two concepts that we have, they work together, but we need to work separately. In the case of the ventilation involves air replacement rate, where we will improve the air quality inside of the barns, injecting fresh air, with some specific rate, removing humidity, gases, and dust. In the case of the temperature, the idea is to keep the pigs in their thermoneutral area to maximize the performance. So when we talk about the ventilation, we try to involve both topics, but really the correct concept is environmental management, no?
Yeah, no, I completely agree, Fernando. And I think, ventilation and temperature go hand in hand. But when we talk about it, we have to make sure we keep our goals separate and we separate management and keeping the pigs in that thermal neutral zone. Thermal neutral zone is kind of the zone in between cold stress and heat stress. It's kind of where we're targeting to keep our indoor environment in terms of temperature and within that range. We go too cold, the pigs tend to eat more. Cold stress and heat stress, it's kind of where we're targeting to keep our indoor environment in terms of temperature and within that range. We go too cold, the pigs tend to eat more, grow less. They get too hot, they eat less, don't grow as fast. So for ventilation, we try to keep it in that zone. And also it kind of leads into the management side of, in wintertime, we often tend to operate on the lower side of the thermal neutral zone to balance heating costs with feed intake versus in summer, we tend to lean towards the upper edge of the thermal neutral zone to, again, balance feed intake with the cooling capabilities of our ventilation system.
So when you guys think about the question then of why ventilate, that seems like maybe a very common sense answer, but talk to us a little bit more about the science behind that and what both of your experience has been with ventilation in swine facilities.
Well, maybe we have two reasons. No? The one reason is, of course, the animal health and improve the activity for mainly the feed intake. But of course, the second is to provide a healthy environmental for our staff. No? So in the wintertime, we are ventilating because we want to remove the humidity. We want to keep gases in control. our environment, supplemental heats. But in the case of the summer, maybe we want to keep the pigs with temperature control by cooling system use.
Well, and Brett, I think you could probably add some clarity here too, since you do have an engineering background. How do producers go about maximizing ventilation or setting up ventilation? Like, let's say they have a new barn or they have an older barn that they're trying to upgrade the facility in. How do they involve ventilation as part of that component?
Yeah, ventilation should really be part of every step of the process. I think sometimes it gets left out to the end or is talked about in the beginning and then doesn't get addressed again. Ventilation has to be through the design, the installation or construction side, then also in the commissioning side to make sure it fully works. So if doing a remodel or a new build, ventilation has to be in there because we need to make sure we're getting equipment size correctly. During the installation part, we need to make sure it goes in the right spot, just because there's too many times we see things being placed in front of inlets, buildings not being tight enough to hold a static pressure during minimum ventilation. We want to make sure our fans, heaters, everything's placed in the right spot. Then also when we get into actually when the project's finished is going through and actually testing facilities, there's a lot of times where things go different in that installation and design process that ends up with unique ways of managing. It's not as straightforward as one would think, and we have to kind of go around different ways to make sure it all works the way we actually wanted it. So it has to be in every step of the process.
And when you guys are dealing with different time periods of the year, like Fernando, you're mentioning there, you want to keep heat in during the winter and push heat out during the hotter months. How do you go about making sure ventilation is not only doing what it's supposed to, but is efficient in your facilities?
I think one of the more important pieces when we talk about the environmental control and ventilation is know your equipment, know what is the challenge that we have in our equipment and establish the goals in terms of the humidity, goals in terms of the airspeed at inlet, two of the most important indicators when we talk about the ventilations. Humidity goals less than 65%. In the case of the inlet, all depend on the facility design that Brett mentioned. Most of the time is between 400 until 1,000. We have a large range here, and through the specialists and in accord to the design, we could decide what will be the airspeed that we want. And in accord to that airspeed, we could calculate what will be the inlet opening and everything that we need. Of course, in the pig side, we have some specific calculation about the CFM per pig needs in terms of the winter time and the air exchange rate in the case of the tunnel or summertime or maximum ventilation.
And furthermore, how do you go about measuring you mentioned humidity goals less than 65%. How do you go about measuring humidity levels and gas levels? There's
some tools that are commonly available that producers can use for humidity. We like portable weather meters that can do humidity, temperature, and airspeed. They're somewhat inexpensive. They're handheld that can be used in the barn. One example would be like a Kestrel 3000. Also for gas levels, there's a few electrochemical sensors that can be connected to more modern smart controllers, versus there's also little glass tubes that one can use for a quick reading if they want to do a more long-term solution.
So, of course, as we've talked about here so far, just to recap, ventilation is, of course, affected by weather and other external factors. But how do we control for things like disease when a lot of those other external factors like weather are something we can't control?
The people know very well about the humidity and a disease challenge, no? When we have high humidity, we could promote the increase of the bacterial, some virus, or fungal levels, no? And in that case, we could produce problem in our pigs, no? One example, Brett, is, the electric particle ionization, the EPI system. In 2009, 2010, they developed those kind of the dealers or the company are selling this system. They are running some trials on nursery pigs. So I remember in that moment when they reduced the dust, and the dust, when we have a good ventilation system, we could reduce the dust inside of the building. No, they reduced close to the 11% mortality in nursery pigs in those trials. And most of the time when we are reviewing this kind of the research, we can find that level. So this is a good indicator of how we could improve the ventilation rate, reduce the dust in the environmental, and impact in pig survivability. No, those guys, the Peterson, I think that is the author of those trials. He worked with pig with challenge, PERS challenge, and they reduce in that case almost 40% mortality when they improve the air quality inside of the building.
Yeah, excellent points. And I think what's interesting about dust is it tends to, it's a compound effect with when you have dust, humidity and gases, that all three of them play a role. It's generally not one or the other that can be the impact, but when you get inside a barn, it's that synergistic impact of all three of those acting together. And I think dust is a big one that I think we'll probably learn a lot more about here in the future.
So I wanted to ask this question as well. Probably should ask this earlier on in the conversation, but with each of your roles and backgrounds, you've had a lot of experience doing research related to ventilation. Will you walk us through maybe some of the big picture, high level research projects that you've worked on and how that's played out here into each of your roles?
We review from maybe 1995, 97 in the United States are running some trials about the advantage or disadvantage of channel versus natural ventilation barns. Iowa State developed those in 1998, I think, developed a trial with 700,000 pigs, and they found United States 10% better or improvement in mortality when we are working in channel versus natural ventilation barns. And that is a one indicator of how we could improve the condition of the pigs in terms of the stress, cool stress or heat stress when we are working with contra-ventilated system. More or less in 2019 or 20, I reviewed some results in United States, outside of the United States, in terms of the automatic curtain versus tunnel in winter and summertime. In both cases, they are reducing or increasing the number of the full value pigs or decreasing the mortality by 10% or 8%. So that is more or less one of the good indicators how the ventilation system could improve the pig survivability by improving in air quality or reducing the environmental challenge. When we have some PED outbreak, that is very interesting because ventilation rate need to be improved to remove the humidity and dry slat when the pig has some PED problems. Perhaps it's a combination between heat sources and ventilation rate, but it's very interesting. And we have some specific studies say when we improve the air quality, we could improve pigs with PED challenge, the performance mean.
Interesting. I'll be curious to learn more about that. That's some good work. In terms of, for me, as some of our research is still all kind of wrapping up at the moment, but earlier done work on creating sensors and doing more spatial temporal analysis of different styles of ventilation and looking at basically different ways to improve ventilation control. But we have some more interesting studies wrapping up on the use of pit fans versus no pit fans in winter and summer, other things along those lines.
So in both of your research, in working obviously in this field, you've probably ran across a lot of challenges that the ventilation field faces. What are you seeing as the main challenges, and how do producers go about troubleshooting in ventilation challenges?
At least from my side, in the visit that we are developing for ventilation, insulation is one of the typical opportunities. Inability to maintain the static pressure is other. Controller settings incorrect is other. Oversized heaters or fans and minimum number of the fans for minimum ventilation calculation could be other of the more important challenge. Airspeed goals. Most of the time when we are asking what is the goal, nobody is measuring or nobody is having some, or the tools to measure that.
I was going to say, if you and I knew the answer, we probably wouldn't be here. Yeah, for me, it kind of going along Fernando's thought on insulation. It's infill leakage. The key to ventilating in winter is having a tight barn to have static pressure control and really get the air speeds that are inlets for good mixing and distribution of fresh air. during those cold winter months when we're most of the time in a minimum ventilation setting. Also along those lines, be just taking the time to do it every day, to look at ventilation. There's a lot of times where ventilation maybe doesn't get looked at as much as it should, but spending time to go through it and really just focus on ventilation, because there's so many other things to focus on in a barn that sometimes ventilation, you get used to it, right? It's always there. It's always running. You might get complacent with it, but it's one of those things where if you're kind of thinking about it every day, and Fernando mentioned if you got the tool there, you got a checklist with you, you got something that kind of sparks and keeps you on top of it, is a real important key to ventilation success.
And is temperature and ventilation success something that drastically impacts pig livability? I
would say yes. Well, sometimes temperature directly does. On the ventilation side, I think we're still learning a little bit more about that. But it's one of those things where if sometimes temperature might not be the direct cause, but oftentimes it is. Same with ventilation. It's not probably going to directly lead to a mortality unless you have a very high level of hydrogen sulfide, but that generally only occurs during agitation and pump out. Otherwise, it is going to make things better or worse for the pigs. And Fernando mentioned some good examples of how air quality and exchange rate play an important role in either making those health challenges better, pigs coming over quicker, or just making it worse. So.
And additionally, in the case of the sow unit, the typical example is in farrowing houses, how we could improve the pre-weaning mortality when we are reducing the heat stress in sows. So we have some measuring, and we can check some paper where the pre-weaning mortality could be reduced by 20% when the people are using the cooling system versus a typical natural ventilated barn. When the sows are uncomfortable with their temperature and they are trying to reduce their heat production, so they are having more movement in the crate, and they could produce mortality in their piglets when they are in lactation process mainly.
So how do you deal with temperature fluctuations like that, or situations where obviously the sows are probably warmer, they need to be cooled off, but piglets, when they're first born, need to be warmed? How do you deal with those fluctuations?
Well, you have their own comfort zone. It's similar than in win to finish barn. The pigs at birth, or the pigs when you are receiving an early pig care procedure, you have a comfort zone. You are providing a specific temperature for them, but the room temperature is completely different than the comfort zone. The comfort zone is warmer, and the idea is to have an excellent comfort zone to reduce the room temperature to be more comfortable to the rest of this. In the case of the farrowing house at the south, in the case of the win to finish barn, to reduce the propane cost.
Ted, and in the creep areas for piglets, we use some form of supplemental heating, such as a heat lamp or a heated mat to help create that microclimate in their much warmer comfort zone.
Yes, and the temperature fluctuation is one of the big things when we are working in the temperature. Maybe those challenge could be coming from the curtain settings, the incorrect bandwidth, in some home is too narrow, or incorrect prover placement, or heater setting could be incorrect in terms of the differential or offset points.
As we near the end of today's podcast, it's important to talk about where we've been with ventilation and where we're heading. Because as we all know, the swine industry changes day to day and year to year. So it's important to note that the hogs we're raising and the environments in which we're raising them in now are not the same as they were even just a decade ago.
We have three different sources to say the pigs are not the same than before. One is the industry. The industry is increasing the market weight through the years, more or less 1 pound per year. So, of course, maybe 10 years ago, the pigs was in 270 pounds. Today, we have pigs close to the 285 pounds, and they are growing in the same facilities. Of course, we need to change our temperature curve because the pigs are facing different challenges just by weight. The second is about the heat production, and Brett could talk more about that. The heat production is increasing through the years in the same pigs, and Brett has better knowledge than me. And the second is because we are increasing the weight, we are increasing the average daily gain in pigs. The temperature setting need to be different, and before. So the pigs are not the same than before because the weight is different, the genetics is different, and the heat production is different.
Those are three excellent points on and how the pig today is definitely not the pig of yesterday or 10 years ago for that matter. On the heat production side, I'll just kind of chime in on that. As Fernando mentioned, the heat production of pigs today is greater if we look at it on a watt per kilogram basis. But what's also very interesting on the heat production is how out of the total heat production, we have heat can be broken down into sensible and latent heat production. And what we see is actually the sensible side is lower than what our latent heat production is. So the pigs, while total is going up, the ratio between sensible and latent is changing when we start to get into earlier heat stress, again, which is going to change how we probably eventually cool pigs a little bit as they are producing a lot more moisture as they get warmer.
Just because today we are changing the weight, from 270 pounds until 280 pounds, the pigs need, or we are having a challenge in opportunity. For example, stocking density. Today, those pigs could increase stocking density in 3%. The feed space per pig could be increasing 1.3%. I am talking about the needs, feed and water intake. Today, we have 6.6% more in pig with 280 pounds versus 270 pounds. The heat production is 1.7% more. In the case of the transport, the pig needs 7% more spaces. So just because we are changing the weight, those kind of indicators are changing, we need to review them. But most of the system are not changing their system. They are receiving in the same number of the pigs per barn, but we have more heavy pigs. The pig has more average daily gain, so they are producing more heat, and the heat production in the pigs are different too.
So as we wrap up our conversation today, it's tradition that we send home our audience with a challenge or take-home message. Admittingly, ventilation might not be an easy one to implement or fix, but there are still things that producers can actively do to improve.
So I think 3 good ideas for people to take home is make sure to check infiltration and leakage. I know we're going into summer now. Leakage makes ventilation during cold weather very, very hard. If we can make sure we take care of the easy leakage, the noticeable ones, if you can see daylight coming under your door, you need to get the sill fixed. Other holes in curtains, plastic round unused shutters for the hot weather fans, any other way that we can cut down on leakage will give us the best chance at ventilating in those low cold weather stages. Then the other one is I kind of mentioned this before, is keeping ventilation kind of at the forefront, making sure we're going through a checklist or something of that nature as often as possible so that we can kind of keep in mind just making sure everything's working right. When something doesn't work, sometimes it's bad. Usually it eventually could result in some pretty bad failures. So we want to make sure settings are right, equipment's functioning, maintenance is getting done, things are doing what they're supposed to do. And again, it's just keeping it on that forefront, because a lot of times it just gets blended in with a lot of the other tasks, especially if you're in the barn every day or not. We want to, it is really the 24/7 employee. It's working really to provide that air exchange and temperature control inside the barn. So we need to just make sure it's doing what it's doing and making sure it's effective as well.
In my case, maybe 3 takeaway could be know the ventilation system and their capacities as a first point. The second is establish your goal, talking about the humidity levels, talking about the air speed at inlet and at curtain when you work in tunnel or you work with wintertime or minimum ventilation or inlet phase, and measure the goals. Use your anemometers or any tool that you have to measure if those goals are be achieving or not.
Like Brett said, it's summertime. We have yet to reach some of our hottest days, so it's imperative we start thinking of ways we might be able to improve ventilation to keep pigs healthy and comfortable once those days come around. We hope you and your herd keep cool this summer, but until next time, you can catch up on all the past episodes of the PigX podcast wherever you get your podcasts. I'm Delaney Howell, and this has been the PigX podcast.
PigX is a national podcast hosted by the Pig Livability Project partners at Iowa State University, Kansas State University, and Purdue, and supported by the Iowa Pork Industry Center. For more information on the project, head to www.piglivability.org, or to inquire directly with questions regarding the project, email ipic@iastate.edu. PigX, ideas in the swine industry worth sharing.